Hi, Mr. Crane here again. I'll try to be real quick. This is for worksheet 3.3 or Magnus lesson 3.3. This is a tutorial for you to help you get through this assignment. So I know some of you virtually do not have access to magnets. So I'm going to give you a way to do this assignment without magnets. This will be real quick. I'm not going to go through each one, but I will go through the first one for you. So it says draw what you hypothesize the magnetic fields will look like around a single bar magnet. Include arrows that point in the direction the compass points north, read by convection. Or I'm sorry, read by convention. So they're saying make sure your red end is north. Okay. So this is a single bar magnet. So over here in the simulator, and you can click on the simulator from a couple of days before. It says magnet simulator, PFET magnet simulator. I have a magnet, north and south end, and I have this compass that I can interact. And you see what happens. When I bring on a normal compass north, the red needle points to the north. Okay? But on our Earth, the actual North Pole, the geographic North Pole, is a south pole of our Earth magnet. What that means is our North Pole, our north of a compass, this north end of the compass would point to the south. And I can prove that to you by showing you that on a magnet, my north end will point to the south pole of a normal magnet. So right now, I can move it to this end, and the north end of the magnet will make the compass needle south end face it. Opposites attract. So a compass that you just pull out naturally and hold. I'll get one for you. A compass that I get, and I'll try to flip it over so you can see it. A compass, I let it go. This compass needle, the north end is pointing towards the north, which is this way, which is towards Fayetteville, which is towards the North Pole where Santa Claus lives. So this north needle you see right here is facing this away. Right now it's facing up because there's liquid inside here. But if I see if I can turn it down this way so you can see it, that needle is facing that direction, that direction. And that direction is north to Fayetteville, to Rogers, to Minnesota, and on up to Canada. So it is facing north. And it must be attracting end, a north end of a, it's facing north, it's the north needle on that compass is facing a south pole, just like this right here is facing a south pole of a magnet. I know that's crazy sounding, but opposites attract. And this north end would have to be attracted to a south end. So you can use this little symbol here to help you answer the questions right here. Draw what you hypothesize the magnetic field will look like around a single bar magnet. Right there, you can see what a magnetic field will look like. That's exactly it right there. So I could actually use for you guys it's Control Shift and the little tiny screenshot button up at the top. But for me, it's Function Shift S on a computer like mine. And this is my magnetic field right now. I could just grab this right here and highlight that, and then take it over to my actual assignment right over here. Get my mouse to right here and paste it. Control V, paste it, and there I have a magnetic field. Okay, so this one says draw. Okay, so you actually have an insert drawing function right here. And if I do this, I can pull up this drawing feature. And inside this drawing feature, I have shapes. So I could draw a simple rectangle magnet. Use this right here. Draw this like this. Do like that. I have a normal magnet. I could pull this into here. This is I use the text box to type in north. And then I use the text box again to put in my south. And then it said by convention. So I could draw a line from here to here. I like that. So I have that. And then I use I was looking for fill. I think I'll go back and let me retrace my steps real quick. Okay. So if I have my box right there, I could resize my box a little bit, and I could do another box right on the outside of this box. That way I can have from here to here, and that'll be my north end right there. When I get this little wonderful fill feature here, and I can fill that with a red. So now I have a red right there, and then I can put my text box in here, and I can have north. And then I can put a new text box down here, and that is south. And now I have my magnet. See that? So now I can take, and I'm looking at my PPET simulator. I can see that my red tip of my dipole is facing the north. And by the rules of magnets, when I'm drawing my field lines, I'm going to pick arrows for this way. I know that it comes from the north and goes towards the south. So I can grab this and pivot it like this, like that. And I can grab that and I can hit Control C, which is copy it. And I hit Control V, and then I just get it and I start moving it. Because I know that this arrow should start going around to, I'll hit Control V again, should start going around to my south pole. Starts from the north, goes to the south. I'll pull that so that it's touching it like that. Do another one. There, rotate it like that. A little bit more rotation. Maybe move it so it's touching it like that. Maybe I'll do another one. Do that for this side. Do another one. Rotate that around. Pull that over here. So what I'm trying to do is get something that's going to look like my drawing that I did earlier, or my image that I saw on this PPET simulator, where I can see that those north arrows, those little red tips, are going, and see how they're turning and they're going back around over here. So that's what I'm doing here. So I'm going to use this again. I'm going to turn this around like that. Use this again. Just keep doing this until I have a good picture of I'm going to move that one up so I can even turn it. Turn that around and grab that thing and bring it back to here. Control V again. Do the same thing with this one. Turn it around. Grab that. And I don't have to keep doing this. I can do like that. So I know that my arrow, if I bring my compass in here, if I bring my compass and I start moving that arrow around, I know that it's going to come back to something like that. I save and close, and it's probably down here. So I want my question number 2 to be with that. So now there's my question 2, just like that. And this one here says, draw what you hypothesize a magnetic field would look like around 2-bar magnets. So I'm not saying you have to reinvent the wheel, but if I Google 2-bar magnets with magnetic fields and see if there's any images like that. Two-bar magnets with magnetic fields right there. Look at that. Actually, I saw one I liked a little better right here. Look at that. Isn't that a gorgeous one right there? I'm going to copy that image. I'll come back to my assignment because this one right here, this one says, they both all say draw, but I'm a little lenient right now. So there's our image right there. But one of them I want you to draw. So I want you to draw what you think. And it says in any configuration. This one here should say that, but it doesn't. So that's what I'm saying. You can do that real quick. It took me literally the time that we've been on this video, 2-3 minutes, to do 3 of the questions. And then you can do the 4th one. Draw how it looks when you measure it. Draw how it looks when you measure it. It should look something like this one here, but with 2. So you can use that to help you draw it yourself. All right. So hope that was helpful. Excuse me. Good luck, and I'll see you on the flip side. Bye.